Hi, how are you? I hope it's all good. Today we'll look into how to calibrate probabilities, that is the model output. Calibration for actual probabilities using Isotonic, Logistic Regression and Calibrated Classifier CV, that is a cross-validation. Now, we are aware that most machine learning models for classification results in between 0 and 1, which again can be interpreted into probabilities by calling predict_proba. But there's a catch. When we do it in iterations, let's say we have used a random forest, which is an ensemble method, having the number of decision trees. The random forest prediction is done by averaging the individual decision trees results, correct? Now, let's say a model predicted a probability of 0 for some sample data, and for sure the other individual ensemble decision trees results will predict a slightly higher value. Taking the average will push the random forest overall prediction away from the 0. Make sense? That's why we need calibration of our probability scores. The idea of probability calibration is to build a second model called calibrator that is able to correct them into actual probabilities. Calibration consists of a function that transforms a one-dimensional vector uncalibrated probabilities into another one-dimensional vector of calibrated probabilities. Let's take an example. If your model outputs a prediction of heart failure in the next months, the doctor for sure will start acting on the people whose risk is above 0.5% probability score. Now, if your model prediction is not calibrated, the model outputs may mislead anyone taking action based on its immediate model outputs. A calibrated model with a score of 0.80 probability score will actually mean the instance has an 80% chance of being true. The easiest way to assess the calibration of a model is through a plot of calibration curve, also known as reliability diagram. The idea is to divide the observations into bins of probability. Thus, the observations that belong to the same bin shares a similar probability. At the same time, for each bin, the calibrated curve compares the predicted mean, that is the mean of the predicted probabilities, with the theoretical mean, that is the mean of the observed target variable. Here this is what it looks like. The calibration curve with an S-shaped pattern is often the case for many classification models, and the consequence is usually over-forecasting low probabilities and under-forecasting the high probabilities. There are three methods we can use it as calibrators. Logistic regression is a rare piece that actually produces calibrated probabilities. The reason behind that, it is optimized for log odds, which makes probabilities actually present in the model's cost function. This is also known as plate scaling. Next is the isotonic regression. It's a non-parametric model that fits a function to the outputs. And last, the calibrated classifier CV. Probability classifier with an isotonic regression or logistic regression from scalar. But do remember, calibrating the model does not guarantee an improvement in the existing model class accuracy in the matrices like accuracy, precision, or recall, which also plays an important role. The most common types of miscalibration are systematic overestimation, systematic underestimation, center of the distribution is too heavy, tails of the distribution are too heavy. The other use cases we can think of is ensembling. When we want to combine many probability models, having uncalibrated predictions makes a difference. Now, let's see this in action. We will try out with various combinations. First is the random forest, second random forest plus isotonic regression, and the third random forest plus logistic regression, and we will compare the results. Here we will create a random forest classifier with the model. This is our regular stuff. Done. Now matrices to assess which one is better calibrated. Expected calibration error gives how far is our predicted probability from the true actual probability. Okay, let's create the isotonic regression. Here we have the results: random forest plus isotonic, random forest plus the logistic regression. Now let's try it with the calibrated classifier CV. It's a package that comes from sklearn that has both the options like isotonic and the logistic regression. Here we are. We just have to call the function and define the method sigmoid, or we can define isotonic. That's it. Here we have a perfectly calibrated results. That's it, done. I hope you will find this article very useful. You can also check my Kaggle implementation in the description below. Thanks for watching. Enjoy machine learning.